Hey, Joel.
Hey, Scott. How's it going?
Going. Just trying to catch up. Oh, that's not.
Hello, hello.
Hey, Cesar.
What up, boss?
Good evening. How's everyone?
Doing well.
Good. All right. Sorry, I'm a couple of minutes late. Let's see. Here. All right. I see Dan on the line. Hey, Dan.
Cesar.
Scott and Joel. Hello.
Hey.
Andrea. Hi, Andrea. Ivana and Lisette, Casey, and Michelle, and Erica.
Hello.
Hi there. Okay. Happy Tuesday, everyone. It's been a busy week for me. We are here in Autodesk. We are getting ready for a new product in April, and I have to do all the marketing material for what's new on Revit side. So there's been a lot of recording here on my end. So let's see.
Sounds like fun.
Yeah, a lot of fun.
Hey, Cesar.
Yeah,
Do you know the name Lynn Allen?
yeah. She used to be a big name in Autodesk.
Yeah. She was my teacher way back when.
Oh, really?
Yeah. Lynn was awesome. I loved her.
She was a guru of AutoCAD.
Oh, she was the master.
Yeah.
Yeah. All right, cool.
Yeah. Now I think she's now with the competition. She might be either with Bentley or with another one of our competitions.
Oh, no kidding. She finally left. Wow.
Yeah. It's been a while, maybe 3, 4 years.
Oh, wow. Yeah, she
Yeah.
taught me CAD back in the DOS days.
That's amazing.
Yeah. It was great. I used to always be able to call her up with help, or I used CAD a lot, so I could always find issues, and I'd always call her with complaints or issues, and yeah, a lot of stuff got fixed because of me.
Wow. So
Yeah.
you learned CAD back in the days of DOS?
Oh yeah. What was it? Let's see. One was a new program or a new drawing. 2 was open and existing, or I got, boy, it's been so long. Yeah.
Wow.
I think it was 7, AutoCAD 7, I think I'd started. Something like that.
Yeah, that was DOS.
Yeah.
I think it was with AutoCAD 10 that it was shift to Windows.
I think, that's what I think. And I finally, I kid you not, 2 months ago, finally just threw away my AutoCAD I had on 3.5-inch floppies.
Oh no, you should have taken pictures. You know, AutoCAD just turned 40 years this year. And,
wow.
And for the last month for celebrating that date, one of the technical specialists in AutoCAD did a live demo of AutoCAD 1.
Oh, geez.
And it was
Wow.
working. It was amazing to see it because it was, yeah, it was a floppy disk version.
Yep.
And he did a very simple house. Not like the Miller house, but it was something very similar.
Yeah. That's crazy.
I can't believe it's 4 years already.
Yeah.
Who knows what happened in 4 years?
Yeah.
I'll be retired by then, I hope.
Yeah,
Okay.
about two more years, 2.5.
Oh yeah.
Yeah. Hopefully.
Yeah. All right. Let's go to business. For today, I think last class I rushed a little bit towards the end. I was trying to get into the rendering process and creating a view and using the cloud. And I might have rushed the last part. So I'm going to go a little slow today and review again the process of creating a camera and go more into the settings of a camera, which I think I did a very good explanation. And then also, since we are almost done with the Miller house, I thought that I could also, now that we have the model almost finalized, we can extract some views, place them into a single sample sheet, and create a little wrap-up document of everything we did with the house before we move into the next half of the class. All right, I'm going to share screen here. And let's see, I'll close this thing here, move this here. Yeah, we are on first of the month. And I'm going to move this. I'm going to see how I fit this in the next few classes. I think I'm going to catch up on the 10th because a lot of the drafting views and details, we already saw half of this topic, so I'll catch up then. I want to wrap the discussion on renderings and then move into ramp, stairs, and railings. All right, for today's class, if you want to catch up with the model I developed at the end of last class, in the chat panel, I'm about to paste this model called Start 7. You can also grab it from the drive. I'm going to be working on the 8, so it stays. Don't use the 8. This is the one I'm going to be used today. And feel free to use that or follow your own work. And don't forget to write your initials in the attendance sheet. Gosh, we're on week 6. Time flies. Okay, so this is the model where we stand. If you recall, last class, we finalized placing some of the furniture inside. We created the little kitchen. We placed the upper cabinets, the lower cabinets, we were basically finishing the interior layout of the house. There are a few things that I think I need to review with you all. One is the process of adding custom finishes to surfaces. That's an important one. And I'm going to use this wall as an example so that you understand what I'm talking about. Let me display the images here again. All right, so notice how inside the Miller house, there's a portion of a wall on the right side, which has a concrete finish. It's probably a different type of wall. But I'm going to show you how we can apply custom finishes to surface. Another thing I'm going to talk to you is how to add decals. And decals are images that span inside a dedicated surface boundary on of any geometry. Then I'm also want to talk more about the camera and a few more tips on the rendering side. All right, so let's start by creating, let's open level 1, floor plan level 1. And I am going to open a elevation. Actually, in this plan, I'm gonna show you how to split a wall. I think we've done it in the past, but we are on floor plan level 1, and the split command, it's in the modifiers. It is this icon that looks like a lingot divided in two. All right, and so if you go to the Modify tab and hit the split element, the cursor turns into this X-Acto knife, and it does exactly what an X-Acto knife does. You select a place in the wall to be split, and in my case, I'm going to split the wall at this point. It'll be right at the perpendicular face of the perpendicular wall, and that's where I click. And then I hit escape. Notice that blue line right there. It's an indication that there's a wall split, and then that wall is divided in two. Escape. That's going to, now I have a wall that is made of two segments. And according to the image, this wall and that wall, these have a concrete finish. And I'm going to show you how we can apply a different finish to an existing wall without the need of creating a new partition. So let's create an interior elevation. So to create an interior elevation, you go to the View tab, and then you hit the elevation tool under the Create panel. Just hit the elevation. And there are different elevation family types. You don't want to create a building elevation because that's an overall, and it has a different scale, and it has a different view settings. But you want to pick in the type selector is an interior elevation. There's only two types in the type selector. And then you're going to see that an elevation marker gets associated with the cursor. And notice as I move the mouse in the Revit plan, the main direction or the main arrow of the elevation marker rotates. And what's happening is that Revit is trying to align the symbol arrow to the closest surface geometry. And so if I get closer to this wall, the arrow is pointing in that direction. If I get closer to this one, it is pointing north. And so you want to make sure that the marker is pointing north towards the wall that I just split, and hit escape after you place it. Now, this marker is been programmed to report the name of the elevation in the arrow. This may or may not be the way you do things in your office, but it discloses the name of the elevation. The name of the elevation is elevation 1A, and you're gonna find it under the project browser, under the elevation tree, and that is the elevation 1A. Elevation symbols come empty because these information get populated once the view is placed into a sheet. It needs information about the sheet number and sheet and detail number in order to add that information there. And you can double click the elevation arrow to move into that view. So move over hover over the elevation arrow, double click, and there you go. That is the interior elevation. And so notice how all the sections that intersect with interior elevation will be displayed accordingly. And like if I want to move to that section, you can just click there or open this one and you have a different section. Now this one is displaying that horrible plywood texture. We'll take care of that. So you with me here? So the wall that I just split is this one. I just click in order to select it, you just click on top of it. And what I want to show you how to do is to apply a new finish on top of an existing wall. And so this is the view boundaries, the crop boundaries. This is called crop boundaries. And the crop boundary, it's exactly as a viewport in AutoCAD. It's a view inside the 3D geometry in alignment with a work plane. And so you can grab the handles at the middle of each of the boundaries to extend the crop region. And this is going to end up becoming like a section / elevation. It's important to display the whole wall. And so this is the piece of wall that needs to receive a different type of finish. And so one way to do that is to use a new command called split face. And on a split face, it's a command that selects the surface of a wall or any surface, and then you can create a boundary on top of that surface that will receive a different texture. Unlike creating a new partition, this is only creating a surface texture representation. It doesn't generate volumes of material because we're not actually creating any material thickness. We're not creating new layers of assemble. All this is doing is patching or applying. It's like a paint, applying a brush of texture on top of the surface in the boundary that you designate. And so the way I'm going to use this is you select The command is available on the Modify tab. So hit the Modify tab. And then it's an icon that looks like a little TV. And it's called Split Face. Hit this Split Face button in the upper left side. Let me bring my nice highlighter here. 1 second. Highlighter. There you go. All right, this is the icon, split face. And then the cursor turned into this little box. It's attempting to select a face. And then you just click at the edge of a wall. And notice that as soon as you click on the wall I want to resurface, you will see the fall boundary. That orange boundary that you see is the boundary of the wall. And so I can use the pick line tool to define the boundary that's going to receive a new texture. So I click the pick line tool, and then I pick each of those yellow lines. And then you can just use the trim extend corner or the fillet command in order to close the boundary. And what I'm telling Revit that this boundary is going to be a split face in the surface of that wall, and it's going to have a different material. Again, the command was split face, is under the Modify tab, this little icon that looks like a TV, and then select the wall. It's going to disclose the yellow boundaries and hit the pick line tool and pick each and every of those yellow boundaries, and then close the boundary using the fillet or the trim to corner.
Cesar, when I choose split face, it doesn't pop up this draw mode, you know, where you pick a line.
All right, glad that you stopped me. I'll repeat it again. So you go, you know what, one thing you can do is enable pick by face, because that's going to make it easier to pick something in by clicking right in the middle. So in the lower right side, enable select element by face. And then I go to Modify tab. And then you go to the split face. Because I have select by face enable, I can just pick any point right here. And you should see these yellow boundaries. Let me know if you get it.
Yes, yes.
Okay. And now that you have the yellow boundaries, you can use the pick line tool, or you can just retrace it. Maybe it's easier to retrace it. And you can go from here to here. I'm creating a loop of sketch lines. And then hit the green checkbox. Oh, I got this error. It doesn't like it. But let's do it partial. I think it doesn't like it that it's this is the whole thing. Let's try it again. So click the red cross in order to exit the command and cancel. And let me try it again. So we go to the Modify tab, split face, select the element by face. And I'm going to keep those lines in place. I'm not going to do anything. But then I'm just going to draw a line that it's about 7 foot above the ground from one end to the other. So I'm doing, I'm just creating one little boundary. And what I'm attempting to do is, this is going to be a split phase 1. And this is going to be a split phase 2. And so these two have the ability to be to host different materials. And the only requisite is that you have this line between the yellow lines. Make sure they are perpendicular. If there's a gap, it's not going to work. You have to actually stretch it, snap it to the yellow line. And once you do that, you click the green checkbox. And now I have a split face in this wall. If I want to apply a different material, check this out. I want to do this twice. There's another command called paint. It's right below the split face. When you paint something, you apply a new texture to the wall. And I want to go, that was concrete. So I'm going to pick a concrete precast. And you just click on the material and then click on the split surface. And when I switch this to realistic, then I have the surface of that wall is now concrete. That makes sense? So I could also paint an entire wall using split face, using the paint button. For example, if I want to paint this with the entire wall with a different material, just go to paint. And let's say I want that to be some paint. I think there's a paint here called. There's a yellow parking stripe color. So when you click the parking stripe color and then you select a wall, the entire surface of that wall becomes of that surface. And then hit done. So this method here is to do to divide a surface into two separate materials. This one just apply a texture to the entire surface. So I'm going to undo here. Because maybe my goal initially was to do the entire wall, and this whole wall needs to be concrete. So all you need to do is use the paint tool. So you go to the modify tab, hit the paint tool, look for concrete. Precast, select the thumbnail and click on the wall, and then the entire wall will be changed to concrete, which is what I was going after initially. You can also do this in 3D. So if you switch to 3D, I want to show you another trick, and this is apply automatic section box using the view range of existing floor plans. So let me show you what that is. I am in the default 3D view, is the 3D view in brackets. And there is a very fast way to crop 3D models using the boundaries of the region, of the view region. And you can do that by hovering over this box, then hitting the right click. And you can say orient these to a view. Again, hover over the box in the upper right side, orient to the view, floor plan, level 1. And what this is going to do is crop the 3D view based on the primary region in the model. This is, remember when I was talking about the primary region and the secondary region, this is a very quick, fast way to create crop regions around view ranges. Let me pull the PowerPoint quickly. This is the
Cesar, can you please repeat how you got this?
yeah, what I'm doing here. Switch to the 3D view in brackets. You can just click the little house in the upper left side. Hover over the navigation box and then right click. And then find the option called Orient to View. And then it's going to span the panels toward the left because there's no space on the right. And then hit Floor Plans. I'm just hovering over. You don't have to click. Hover over and then hover over Floor Plan Level 1. And that's where you click. Let me know if that worked, Ivana. And so this is what happening in this. When I activate that thing, Revit is detecting the primary range of the view range. And it's creating a section box using the primary range of values. So these that section box has a height of 7'6" from the ground level. Does that make sense? So you can also create, you can orient your 3D view to different type of views as well. Not only floor plans, but you can also do it in sections. So if you want to have a 3D section of your projection section, again, hover over the box, right click, orient to a view, and hit section 1. And again, Revit is going to align the crop region with the size of the viewport in the section and the view depth. So that's the size of these section box. And I guess displaying, creating this type of section box is very powerful. It tells a bigger story than just a projection box, a projection section. Let's try the other section. Here you go, right click here, orient to a view, and you can orient to the new elevation we created, that elevation 1A. And that was an elevation / section. And this is a quick way to work in 3D. Like sometimes if you have the full thing working in 3D, all the elements displayed in 3D, it's very hard to navigate inside. But if you use the orient to view option, then you have additional 3D spaces in which you can edit and add elements. And so I'm going to use this elevation section, which we created previously, to apply color in 3D. So select this section box, grab the handle, and now I have this 3D section in 2 directions, and I can just paint with different materials. So paint, I use the paint tool in the modify tab. I look for concrete precast. Just click on the icon and then click on the surface. And that applies a different finish, but it doesn't create a new partition. This is just, the only thing I'm doing here is like painting. It's just applying a new texture on top of the surface. And this is great for creating photorealistic views without impacting the design or creating new elements in design. So that's pretty much what I was going after. I wanted to do this concrete wall and apply it to a surface. To return the 3D box to a full display, all you need to do is go back to the properties of the view, scroll down, find the section box, and disable it. And this is going to take me back to the full 3D view. Again, orient to view, it's a great way to create different custom section box associated with the view boundaries, the view crop boundaries. Okay. Any question here? Did that work, Ivana? Not sure if I answer your question. All right, let's talk about cameras. Last time we created a camera, and I did it very quick, but I want to show you more parameters associated with cameras. The camera view, it's available in the upper left in the quick access bar. You know, the drop down menu of the default 3D view has a camera here, and also has something called a walkthrough. So I'll talk about walkthroughs in a second. But a camera, it's a 3D, it's a perspective view, which started with the position of the server and a target point. So when we create a camera, we typically do it in a floor plan. And when you hit the command, the cursor is going to turn into this tiny little camera. I'm going to create, again, a new camera from an observer that is placed in the lower right corner of the house. So that's the first click. The offset indicates the eye level of the camera relative to a specific level. If we have a multi-story, you can pick a different level. Then you select a target, and the target, try to make it as encompassing as possible, because you know the cameras don't have unlimited field of view. They have wherever you click, wherever is the second click, that is the far offset. And so you try to include everything you want to include in the field of view. And then that creates this camera. Now, the size of this crop, this is a new view. It's called 3D View 2. You'll find it under the 3D View branch of the project browser. And this crop region has a size the print size of this crop is available here when it says size crop. So all you need to do is switch to the 3D view, the new camera, select the crop view in the screen, and then hit the size crop. And this is the printed size of this camera. So if I were to place this camera in a sheet and I print the sheet, this is going to come at 6 inches by 4.5. And here's where you can change the size of the printed size of the crop of the camera. So you can stretch the crop size by clicking on this control point. You can do it in X direction or in the Y direction. And again, this is gonna get the, I'm changing technically the size of the crop. If you want to be very precise, you can use this numerical entries, or you can do it intuitively by dragging the control points. Okay. All right, so the part that I didn't explain very well is the navigation wheel. Before I get into navigation wheel, let's switch this to a realistic view to display the textures and study the light. Okay, these when you create a camera, the light is not going to get automatically synchronized. By default, Revit is going to place a generic lighting from a source that it's placed at a top right view of the elements. If we want to make it consistent with the location, then we need to apply a different light. In last class, remember I teach you how to place a location and connect the site to a geographical latitude and longitude. But when we create a new view, we also need to apply the new lighting. And so the light settings, it's under the sun settings, is the third icon from the lower left. Sun settings. And notice how it says in the default view, it just says in session, and it's a generic sun that is placed in the upper right side. The upper right side is defined as an azimuth of 135 and an altitude of 35 degrees. You recall what this concept are, right? Altitude is an angle from the ground, and azimuth is an angle from the north in plan. But this is generic. If we want to connect it to a specific sun on the site, you switch this to a still. And in the last class, I show you how to specify the Spring Norway location. It's already there, and it's connected to longitude and latitude. And then hit apply. And that's 10 a.m. in Norway on March 20. You can change the hour. I think we said that maybe 2 o'clock was better. Not so much. Yeah, I'm going to leave it at 11 or 10 a.m. That's fine. But we can create we can duplicate suns and apply it to different cameras. So if, for example, if in one shot you want to see the spring equinox, you can apply the sun. If in another shot you want to show a different date, you can just duplicate and rename or create a new copy. Make sure you use the same location and save them. The sun settings can be applied to any view. So once you record it in this dialog box, it can be applied to other floor plans, elevation sections, and 3D cameras. Okay, so we took care of the light, the camera, and now we can tweak the camera settings in the navigation wheel. And this is the navigation wheel. I didn't spend a lot of time talking last time. The navigation wheel, which is accessible in the vertical toolbar, navigation toolbar. By the way, if you close this by mistake, which sometimes happens, you can bring that back under the view tab, and then go to user interface and bring the navigation bar back into the view. Here it is. All right, so when you start the full navigation wheel, you're gonna see this bulky cursor with 8 different commands. Each of them are ways to modify and calibrate the camera settings. Let's start with the one outside. So in camera, remember there is an observer person and there is a target. And then there's a line between the observer and the target. That is like a straight line. So when I use the pan command, if you highlight the pan quadrant, what I'm doing in this screen is translating the line between the observer and the target parallel. So all I'm doing is raising this diagonal line. But I'm not changing the direction of the target. So when I hit pan here and you keep it pressed, the direction between the observer and the target remain in the same direction, is the same vector, but all I'm doing is raising it in space, or relocating in space. So you can tweak your views using this command. The other one is zoom. When you zoom, you're actually making the observer go forward towards the target. So again, there's a observer line, a target observer point, a target point. And when you zoom, all you're doing is translating the camera along that line. Again, you click zoom, and then you can zoom in. I'm getting closest to the target. I'm getting away from the target. That's what zoom is doing. And then you release. This is really subtle. These movements are really subtle. So in case you get lost, for example, I did this something, oh, what happened? That's why you use the rewind button. And the rewind button, what it does, it gives you a historical view of all the changes in the camera that have happened since I started the command. So this is like going back in time. And this is all visual RAM that Revit have access to. And it's only valid for the life of the session. So if I close Revit and I try to do this again, this history will be erased because it's just reading RAM information stored at a local workstation, at a local session. So if you get lost, always use rewind, the rewind button. The other one is orbit. I don't recommend using orbit here. What it does is it finds the geometrical center of everything in space, and then the line between the observer and the target is rotated around this orbit point. And so in a way, if I hit orbit here, it starts rotating that line between the observer and the target. You can use it if you wanted to relocate the direction of the target. I'm going to rewind and get back to my previous view. So the other command is this one called up and down. It's at the center of the wheel in the lower right side. This is the equivalent of having somebody grabbing you from the head, grabbing the observer from the head and pulling you up. So all it does is translate the observer position, but it keeps the direction of the camera in the same vector. So try it. If you hit up and down, up raises the observer's location, but it doesn't change the, I'm gonna rewind here. Up and down, it raises the observer location, or it lowers it. If you get lost, you can always use the rewind. The other one is look, and look is the equivalent of the observer grabbing the camera and changing the vector direction of the camera. So the observer is in the same place, but I am just finding a different target and I'm changing the vector direction of the camera. And then center picks a new target. But this is, be careful with that, because wherever your cursor is, that becomes the new target. So for example, if I want that corner of the window to be the new target, I hover over this point, and then I hit center, and then it shifts the observer location. So that wasn't very pretty. So I'm rewinding. And then the other one is this called walk. And this is very subtle. And the first few times you use walk, you might not get it. But walk is it's one way of creating a walkthrough inside the house. It's a way to navigate, to make the observer navigate through the scene. So let me show you how that works. If you hit walk and keep it pressed, right at the lower center of the view, you're gonna see this big yellow dot. That is your navigation tilt. Think of it as a joystick. And then this joystick, if you move the cursor, I'm keeping pressed the joystick. And if I move forward, if I move the mouse towards very slightly, very subtle, very little, when I move it forward, then I am moving forward. Then I switch to the right. Then I move forward again. And again, I'm making micro adjustments, super micro adjustments. And all I'm doing is making a walkthrough of the house. Super slow, super subtle. But this is technically changing the whole view, because I'm basically walking, and I've done this for a long time, so it's easier for me. But it takes time and practice to be able to go slow. Otherwise, you might be running through the space rather than walking. And so the key is to press the joystick and do micro movements to the right, micro movements to the left. And if you know how to use this well, then you can create walkthroughs on the fly and present them to clients. Like right now, I'm here in in the room, and I'm going to turn 180 degrees. And exit. Exit again, and if I get lost, always rewind. You always go back to where I started. All right, so those are the 8 commands embedded in the navigation wheel. I'm not super happy about this user interface. It's a little clunky, it's big, it's not that intuitive, but it's what we have. But these are ways to modify your camera settings, calibrate your view, and find the right position between an observer and a target. All right, to exit the navigation tool, just hit the X here. And now you have a view that's suitable for rendering. Now to render as seen, you go into the render tool, which is the teapot icon next to the shadows icon. And this is a way to render inside Revit. Rendering uses an internal rendering engine, and you can choose different qualities. I'm going to use medium because my machine is very fast, but if you don't have a big machine, don't even try. It might take you a lot of time. You can render to the screen or to the printer. It's just a different way of measuring the size of the image. So if you do printer, it will be a specific size. This is the size of the crop region. If you do screen, it's going to take the full screen of your view. It estimates the size of the image, which is a good indicator, because all that information will be living in your project, and this is how much your project will increase in size. You can choose what type of lighting to use for the rendering. I don't have artificial light, so exterior sun only will work. Or you can do interior sun only. I think that works better. It's an interior shot with exterior sun. This is the sun setting according to the view. You can choose different type of background. The sky, it's blue with clouds, and you select the density of the clouds. You can pick a custom color, or you can choose an image. The image will be displayed at the background. This is if you have a special type of image. I think I have an image in the Miller house. Maybe this, I can't recall. I have one image. It doesn't matter. I'm not going to do it. Or you can do a transparent background in which, the image will have alpha channels that could be swapped in Photoshop with a custom image, for example. You can use it as a mask. But for this, I'm going to do a few clouds background. And then this is adjust exposure is a post-processing exercise. So after this is processing, finished processing, I can come back here and change the exposure control and then render. Now, this is our rendering on the desktop, and it's incrementally refined over time. It takes it was fast. Is this done? No, it's not done yet. It wasn't too bad. But notice that how the exposure is very strong. And so here is where I can come back into the adjust exposure. And I can decrease the exposure value and make it a little darker. You can decrease the value of the shadows. Decrease the saturation. These are all post-production. Decrease the white point. Highlight darker. And the exposure value is mostly what I think. Oh, that's too bright. Maybe that's the best I can do with the sun outside. There you go. That 0.1 is the minimum. Okay, and once you arrive to the post-production edit that you like the most, then you can save to the project, or you can export the image, and then this will be saved as a JPEG that you can use outside of Revit. I'm going to save to the project, and I'm going to give it like interior view. And what that does is that the rendering is going to be saved under the rendering tree in the project browser. And this is going to be an image. It's an image placed inside Revit.
Cesar,
Yes.
so when I do that, open that rendering box, how do you change the width and the height? I was not able to change that, and my rendering is really big.
The width and the height of your crop region, of your crop boundaries?
No, the rendering box, the pixels.
Oh,
When you go to the teapot icon, and then opens here, then the width, you have 976 pixels, and I have 1,500. How do I change that?
this is all based on the size of the crop region. So,
Oh, I see.
so
That we set up before.
976 pixel is what it takes to print a 7.5 by whatever size I have. This pixel number translate to. And
I see.
use a default of 96 DPI, which is good for web, I think. But if you switch to printer, I can increase this. Printer is, I would do a screen if you're doing like web images, where I would switch to printer to increase DPI. But honestly, nothing, I mean, a standard commercial printers can only go up to 300. And then you need a special printing machine to go above 600 dpi, about 300. So, but notice the size, 300 dpi and 600 dpi is not going to make a big difference in the printed quality of a standard printer in an office, but it does a big difference in the size. And this is how much your file is going to increase. And so if you do a high quality at 300 dpi, I would recommend to export the image afterwards and not keeping the image inside Revit, because this file, it's going to be very difficult to synchronize to central. Just export the image when it's finished, and then if you need to change the DPIs, then you have to change the crop region here.
Okay.
Here.
Oh, I see. Okay, thank you, Cesar.
Okay, I'm getting a message that I have poor audio quality. Are you guys hearing me well? Yes? Okay. I don't know what this is then. Okay, so this was printing out of the box. The drawback is that you have to wait for the printing for a rendering to be finished. You cannot use Revit while the rendering engine is running. And so the alternate is to use this rendering cloud, which is connected. It's connected with your cloud service entitlements, and it consumes tokens. And so when you purchase a new license of Revit or you renew a subscription, every user is given 100 tokens. Each token, I think it's sold. You can buy additional tokens for $1 each if you run out of resources. But when you render in the cloud, these credits are in display, so you can see how many your user has actively. How many active credits do you have in the cloud? Obviously, you need a good internet connection. And it's 3 steps. You select the 3D view, select the quality, select how you want to get notified, and then rather than using your own resources, local resources, this is processed by an Autodesk server, which is far more powerful than the one you have access, and then it's done very quickly. The high quality is done very quickly. So I'm gonna render the same image, but I'm gonna do it on the cloud. So you go here, continue, and then you pick the view you want to render. It's the interior view. All right. No, it's 3D view 2. I didn't rename it. So it's the active view. There are 4 types of outputs: a still image, panorama, and a stereo panorama. A panorama, it's a VR. It's a 360 render. The stereo panorama is a higher quality VR. I would use a stereo panorama to create something that you will see like in an Oculus Rift or an HTC Vive headset. You can also create illuminance studies. An illuminance study is a color code overlay on the model surfaces to measure the amount of foot candles. And this is useful to validate your, I think they accept this type of method to qualify for LEED credits. And it does consume some credits. If you do a luminance study, you have to pick a date, and it consumes 1 cloud credit. Because I am an Autodesk employee, I have unlimited credits, a lot of credits that I have available. But I'm not going to do illuminance. I'm just going to do a still image. You can use standard or final quality. I'm going to use final so you know what it is, how it looks like. And then the image size, it's the amount of pixels. And unless you're doing super hyper realistic, I will go to large. But really extra large and maximum, it really doesn't add a lot. I'm going to use medium in this case. It's only going to consume 1 credit. And then the exposure, it's native. There are 2 choices: advanced or native. Advanced, it only allows you to have additional post-processing controls in the cloud engine. So if you're going to do additional tweaks in the cloud, use advanced. You can have a checkbox that says email me when complete, and Revit is going to send an email to the entitlement on record per your cloud service agreement. And then you start rendering. Now, the advantage of doing this is that, oh, I don't know what happened here. The rendering service did not complete your request. I don't know, I think I'm running low in resources because I have this thing on my screen that says you're having a low resources. So maybe that's preventing me from doing it. But if you were able to do that, you're going to see a little circle here in the upper right side next to your profile. It's a visual indication that the render is processing. Let me try it again quickly, but I'm going to pick maybe native exposure, still image, standard. Let's see if that. No, it didn't work. Are you getting this message too? No, it must be just me then. File could not be uploaded, so that means that my upload service in the house, it's an internet problem. Anyway, so you're going to see a little circle next to your profile indicating that the image is getting processed, and when it's done, when it's done processing, you're going to receive a bubble notification that the image is ready. You will also receive an email if you click that checkbox in the rendering dialog box. And if you want to check it, you can go into the render gallery. The render gallery is your cloud repository of images in an Autodesk server. Only you have access to this service. Each user has its own space. These are some of the images I've rendered in the past year. This is the one I did last class, and it's a 360 degree. This is a panorama. But if you send a still image, it's going to appear also as well there. I probably need additional entourage, like more furniture, to make this more impactful. And this is another one I did. I think this was in a previous class as well, but this was empty. It's not too bad, I have to say. And I think for the floor, you can see that I use a photorealistic, a physically based texture, which give me these reflections and this lifelike look. And again, the post-processing that I was talking about, it's under the exposure. You can create additional solar studies. This is a re-render in the cloud using the rendering engine. So if you're not happy with the results, you can always re-render using the render galleria. And create this solar study. A solar study, it's a range of, it's an animation of the path of the sun in the space from one day to another day, from one time to another time. It also consumes cloud credits, but it will process everything on the cloud render, on the cloud engine. Okay, any question about this? I also, now there's a lot of live renderings available that compete with Autodesk. I think the one that's very popular, and have you guys heard about Enscape? Enscape, it's real-time rendering engine. And so it uses local resources to test and create renderings on the fly. It is really good, I have to say. And the pricing is not so bad. So Enscape works for Revit and V-Ray and SketchUp. It's a single seat is like 400 a year, which is not bad. You can have a free trial. But the type of output you can get with Enscape, it's pretty powerful as well. These are great renderings using Enscape. And Enscape work on top of Revit, so it looks like an add-in for Revit. It has its own controls. I don't have it in my machine, but I'm just passing the word. Another one that I believe is free is called Twinmotion. It was free as of a few months ago. And Twinmotion is based on game engines. Twinmotion is created by Epic Games, which is the company that creates Unreal Engine. Unreal Engine is used by the game industry to develop high photorealistic games. All of this is renderings, and they look hyper realistic. So if you want to like go to the end of a game of rendering, I would highly recommend Twinmotion because it's super easy to use. It's integrated with Revit, and the output are just incredible. This is what the big commercial firms use for marketing. I was part of this project when I was working at HOK, and we 3D scan the entire historical city block and move it into Unreal Engine. Yeah, this is all 3D scanned, but it's available on the cloud, and anyone can access it. During the pandemic, this was the way they were giving tours of the facility. Anyway, Twinmotion and Enscape, real-time rendering. No need to wait for a render to be finished. They are up in the game in the visualization space. All right, I hope I don't get in trouble for talking about other products. Any question about rendering? All good? All right, one more thing before moving the page, and this is about decals or decals. I don't know how it can be, if I'm pronouncing it right. In Revit, I'm going to switch to the floor plan level 1, and I'm going to open these interior elevation, the one I created before. So in Revit, there's something called decal. In a decal, it's an image that can be used as a texture in a split face. In other words, is using a custom image to fill a user-defined boundary on top of a surface, and it's typically used to create pictures or embed images inside a feature wall. And so I'm going to switch here to realistic. in this interior elevation. This is the interior elevation I created in the previous exercise. If you don't have this view, just go into a section and pick any of the walls. And so in the Google Drive, I have an image of swan. Where is that spring? Under Mila. Or did I not put it here? I thought I had put it here. Mila.
I think it's in the families.
Oh, it's on the families. Thank you.
Yeah, because it,
Yeah, here it is. The swan. Okay, I'm going to use that swan and embed it as part of the texture of a wall. And I use decal for doing that. And so I'm going to copy, share a link. View. Copy link to clipboard. And then go to the. All right, here's a link to that image. Download it and place it in a place you can retrieve. All right, so under the Insert tab, there is under the Import panel, you can import an image. And this is if you want. Import image is a way to bring an image and then place it anywhere in the view. So these startup images that I had on level 1, or these JPEGs that are lying here on the right side, all these were images that I imported using this method. So the way to bring this image, you go to the Insert tab, go to Import Image, and then I'm just going to bring any image. You can bring the swan image and then place it in the view. Now, this image is view specific. And what that means is it only lives in this view. And it can only be printed from this view. And sometimes you want to do that. For example, if you're creating a section in your construction documentation, and you want to include approval letters or conditional approval statements from the city, which sometimes we include, or you want to include, like I work in a firm that they scan the specs and they place it on sheets. You can bring those PDF or bring those PDF into Revit or convert it into TIFF and bring it as well as images. And there are view-specific images. Now, a decal, unlike an image, a decal can be embedded in an element. And so you have to, if you enable a decal, if you click this drop-down list, you're going to see that there are decal, there are all these different decal types. And decal types are instances that are slated to be used in Revit surfaces. And so right now the decal types are empty, but we're going to create a new one. Again, you go to the Insert tab, decal, and then hit the Create New Decal button in the lower left panel corner. I'm going to call this Swan. And this decal needs a source, so I need to find that Swan image again. So I go and search for the Swan image. that I just shared with you guys. You can change some of the image properties. You can make it brighter, be more reflective, be transparent, change the finish. You can change the image properties using all these controls. And that's it. You just hit OK. Now the decal has been created. I'm going to escape. The decal has been set up. I'm going to switch to that elevation. And now I'm going to place that decal in the 3D space, in this wall, in this surface. So what I need, after defining the decal, now I'm going to place it. And you hit place decal. Select the size of the decal. This is 3 by 2. You can change it. And there you go. This is a 3 by 2 image, and then escape. I placed it twice by mistake. But the difference is now that this is part of the 3D space, and it's going to be visible in every 3D view. It's not view specific. It's associated to the wall surface. You can use it to represent a TV or a picture or a hanging art, or you can actually size it to fill an entire wall, and maybe do a feature wall or something like that. That makes sense? All right. So that's decal. That was images. Here's another one, and this was a new feature in Revit 2021, and that was import PDF. I don't have a PDF, but I'm just saying that you could place PDF files inside Revit, and they are going to snap to the vectors. So that's super nice because you can actually retrace existing conditions from an existing PDF setting, as long as the PDF is printed from either an AutoCAD or a vector-based CAD file. I don't have a sample that I can bring here, but imports are going to be view specific, just like the images. But you can actually use it for details. Typical details can be printed in AutoCAD and save as a PDF, and then you can import as a PDF and place it in a drafting view. And we're going to talk more about PDF later, so I'm gonna delegate this topic for a little later. You can also link them or link images. If the image changes, then it will be updated in Revit. If the PDF changes, it will be updated in Revit as well. Okay, so those are the outstanding topics I have for you. Oh, somebody asked me via email if there was a way to align the exterior finish of a texture with the vector representation. Let me show you how that works. So I'm in the 3D view, and if you recall, this was a shingle that I applied to the wall properties. So in the material, in the exterior, we have an exterior wood slab. And when I switch to shaded, it has a different direction. It has a different orientation. And so to make this alignment between the texture and the hatch, then we need to access the hatch properties and review the image properties as well. So let's review the image properties first. So I'm going to go to the Manage tab and open the Materials Library. And I'm going to look for the exterior wood slab. This is the material I think I created. And under the appearance library, under the appearance tab, if I hit the image in the image parameters, this is what's important. This is how you can size it. This is telling you the size of the square that will be arrayed on top of a surface. And this is telling you that it's a square of 6.5 feet by 6.5 feet. And then I already counted this, but there's a number of 14 rows in 6.5 feet. And all I did was like 1, 2, 3, 4, 5, and there's 14 rows in one direction, in the horizontal direction. And so 6.5 feet divided by 14, that's about 5.5 inches. I need a hatch that is 5.5 inches parallel lines. And that's the information I need in the background. And you can do that with anything. If you have something that is modular, as long as you have access to the sample size, then you can do a little math and find what is the scale that the hatch needs to have. So under the graphics of this hatch, I need to create a new pattern. So I hit pattern here. And I'm going to switch this to a model. And I'm going to create a new pattern, new fill pattern. That is model, because I want it to be precise. And it's going to be parallel lines at 0 degrees. And the line spacing, it's 5.5 inches. And this, I'm going to call this exterior wood pattern. So again, I went into I am in the material browser. I open the exterior wood slab. I'm in the graphic tab. I hit the surface foreground pattern. Switch this to model. Hit create a new pattern. Give it a name, exterior wood pattern. And then it's a parallel lines, an angle of 0, 5.5. This is what I did using the math. This is my new pattern model. And that it's applied to the exterior pattern. And now there's something called here a texture alignment. And when you hit that, it's an overlay of the texture image and the exterior wood pattern. And you can see that using these arrows, I can move the vector display and overlay it on top of the surface so that they are aligned. You can move this vector to the right or to the left. And this looks pretty accurate. And I hit OK here, hit OK. And cancel. And now the same modular spacing of the shingle in shaded is the same that I have in the realistic mode. That makes sense? It's a matter of doing a little math in the modular. Okay, let's save this. Let's see. I almost ran out of time. I think I'm going to close the class then. I still need to go review rails and stairs and railings. For next class, we are going to use a folder inside the Google Drive called Stairs and Railings. So make sure you have that handy at the start of next class. So here is stairs on railings. Keep this handy for next class. And yeah, that pretty much wrap our work with Mila, the Mila house. I mean, we spent 7 classes with it, but we went very detailed. I went very detailed in the explanation on how to put it together. So hopefully you learned something, particular around residential housing. What's next in the agenda is the documentation and data analytics. So I'm going to talk about parameters, how we add custom parameters to Revit, and format the information so that it can be used in the schedules. We're going to do use some of the analytical capabilities of Revit, area plans and code analysis, create details and add 2D components on top of a detail, work with CAD, export files to CAD, and some interoperability. This is going to be a good one, phasing and design options. Phasing is in particular very useful when dealing with existing condition and have a visual representation of existing and new in different line weights and transfer that information to schedules and data. Create sheets and manage sheets, work sets and work sharing. So all of this is about ways of collaborating in the creation of construction documentation. And the final 2 classes is all about family editing. So, okay, I saved this file as Mila start 8. This is our final state of the house. So you can always retrieve it if you want to take a look at. And again, if you have questions, feel free to stick around. Otherwise, I'll see you Thursday, guys. Have a good evening.
Thank
Thank
Cesar.
you.
Have a
Thanks,
good
Cesar.
Thank you,
Thank
Cesar.
you. Have a good night too.
Good night.
Hey, Ivana.
Sorry, I didn't know how to unmute myself when you were asking me. I was looking because I minimized the,
Okay.
anyways. Okay, take care. See you
Hey.
Thursday.
Have you experienced crashing it again or no?
No, no, no,
Oh, thanks God.
no. Good. Thank you. Bye.
Bye-bye.
So Cesar, I have a question. Is there a way to slice a wall horizontally?
This lies a wall horizontally. You mean in a section?
So what, for instance, say on this right here. So say we model out this wall, but we want to have a different wall type for the portion of the wall just below the window. So you do a slice vertically to get there, but say to do that, would you just have to model as 2 walls and do one wall like 3 feet tall, and then the second wall draw it on top of it with like a 3-foot offset?
So are the walls stacked with the same width and different materials, or they have different thicknesses?
They'd have different, say this is, this is our shingles, but then below the window, we have like, say metal panel, finished material on the exterior.
Yeah, that's a good question. I should have shared this with the rest. Let me show you, but maybe
Okay.
share this with
Or if you just want to share with the class on Thursday.
yeah. So let me quickly show you how that's done. I'm
Yep.
gonna go switch to a floor plan. I'm gonna create a wall section. So you go view section, wall section, and then open it and display this in fine. And that's probably not a good place because there's a storefront there.
Oh, you're not sharing your screen right now.
Oh, 1 second. Okay, I created this section, wall section. And
Yep.
Say, for example, this wall, you needed to have a different type of treatment,
Or just say go to the, is there the windowsill?
yeah, this is the window. This windowsill needs to be different from the top.
Yeah.
Yeah. And so there is and I haven't talked about it. Revit has something called a stack wall. And a stack
Okay.
is a combination of two wall types. The primary is set to a certain height, and the secondary it's on top of it.
Okay.
And so the way to build one is I'm going to select one. Over this, you see how these have a
Yep.
different treatment below.
Yeah.
And if this is built, it's because in the type properties, I can combine one wall type on top of another one. And this is a 3'6" is this type. And let's say I'm going to change it. This is going to be like,
Okay, cool. So the name type is where you would choose your, under name is you choose the wall assembly.
yeah. And then
Okay.
on top of that, it's, let's say this is a 12-inch concrete, up to 5 feet. And on top of that, you're going to have a 4 plywood, a 4-inch stub.
So the lowest one in the list of 1 and 2, the lowest one is the one that is closest to grade.
Correct. So
And then it
whatever is-
runs until that height, and then, okay,
and I apply this, and there it is. This is
awesome.
this is a stack wall, but I created a new type. Well, I modified this one. Ideally, I should have a duplicated, rename, and change parameter values.
Uh-huh.
But you can have different treatments, surface treatments, and that will run throughout the wall. Now, the only thing is that in order to tag this in a floor plan, you need a tag for the upper part and another tag from the bottom part.
Uh-huh.
And this wall can only report one tag at a time. And so the workaround is to create a dummy tag that reports the bottom part. Because you can only report one, you know what I'm
In
saying?
plan.
There's one code for the entire assembly.
Yep.
But if you want to report two partition types here,
Uh-huh.
one is embedded in the wall and the other is just text.
Gotcha.
And it's called stack wall.
Cool. That's super helpful.
All right. That's a good
Great.
thing. That I'll share that with the rest of the class.
Sounds good.
Okay, hey,
Bye. Have a great day.
Bye.
Bye.